Find the derivative of f of t equals the cosine of t squared plus 1 over the sine of t squared. F of t here is the quotient of two expressions, the cosine of t squared plus 1 over the sine of t squared. One option is to use the quotient rule to find the derivative. However, we do have a single denominator here. It's not added or subtracted with any other terms, so we have an option of rewriting each of the terms in the numerator over that common denominator. So we can rewrite this as cosine of t squared over the sine of t squared, and then plus 1 over the sine of t squared. The cosine over the sine is the cotangent, so cotangent of t squared, and then 1 over sine is the cosecant, so plus cosecant of t squared. The derivative then can be done by taking the derivative of each of the individual expressions and add them together, since we have a plus sign between them. Now, one thing to notice here is the t is being squared and then it's in the trig function. If it helps, you may want to write parentheses around those, because that square is not on the trig function, it's on only the t, and that makes a difference to the derivative, because that means the trig function is the outer function here, not the square. So we actually start with the trig derivative. The derivative of cotangent is negative cosecant squared, so we'll have negative cosecant squared of, leave the inside alone, t squared, but then we need to multiply by the derivative of the inside to complete the chain rule. Derivative of t squared will be a 2t. That 2t is going to move to the front. It's not inside the trig function. All right, now we also have plus, and we're going to take the derivative of the cosecant. Well, the derivative of the cosecant is negative cosecant cotangent. Again, leave the inside alone, so negative cosecant cotangent of that inside left alone, and now the derivative of the inside, which will again be a 2t that'll move to the front. We could put brackets around this since we're adding a negative, which means we're really in the end subtracting that. And so f prime of t can be written. Let's move to the 2t to the front with the negative. Negative 2t cosecant squared of t squared. And then we have a negative 2t. Again, the 2t can move to the front. Cosecant of t squared, and then cotangent of t squared. So there's our derivative, f prime of t. We do have another option where we can bring out a common factor, because there is a negative, there is a 2t, and there is 1 cosecant of t squared in each of the two terms we have here. So this is an optional way to write the derivative f prime of t. Factor out a negative 2t and a cosecant of t squared, and that will leave us with, for the first term, just 1 cosecant of t squared left over. We took everything else out. And for the second term, just a positive cotangent of t squared. Again, we took everything else out. And there's an optional way, a factored version, to write the derivative.